Hello, graphing inequalities today. We are going to talk about this inequality right here and actually graphing it in, let's say we were asked to give a point, a solution to this thing that really satisfies the inequality. So really you could pick anything for x. Let's just say that we start off with an x value of 0. What we're going to need to come up with is a y value that makes this true. So let's start by subbing in 0 here. So if I put in 0, 0 plus 1 is 1. 1 squared is 1. 1 times 2 is 2. 2 minus 3 would give me negative 1. So you'd end up with y is greater than negative 1, and then come up with a y value that actually satisfies that. That makes that statement true. So when we put in x, well, what would y have to be to make that true? So really, y is greater than negative 1. Well, what's something greater than negative 1? You could start with 0. Is that the only answer? Hopefully you're saying no. What else is greater than negative 1? You could say 1. Okay, only answer? No. What else is greater than negative 1? You could say 2. Hopefully you're seeing that I could say 3. I could say 4. I could say everything all the way up to infinity and all those numbers in between there. That poses some problems, because what if I put in a value of 1? Is there anything that would satisfy the inequality to make that true? And you're going to get a whole nother list of points. So really, you are talking about an infinite set of points that will satisfy this. And that poses a problem because I personally don't want to write down all those points, and you probably don't either. Therefore, we get to use a little bit of art in the form of shading. Coloring in one portion, one zone or the other to represent where all those solutions lie. Now, before we get going, if you have greater than or less than, your graph will be dashed. If you have greater than or equal to or less than or equal to, your graph will be solid. So looking at this, I know that the graphical representation will be dashed. So let's get started by actually just putting this into action and graphing this. I'm going to slide up a hair. There we go. Hopefully you can still see it. If you're not sure about graphing this thing, it might be a good idea for you to take a peek at some of my other videos, parent graph of a parabola specifically for this. So my vertex will be opposite same, -3, -1. My a value is 2, so it is positive. It opens up. I'm going to slide over 1, shoot up 2. Slide over 1, shoot up 2. There is a base for you to get started. Oh no. I shouldn't be using pen. This should actually be a dashed graph. My apologies there. That is why you always want to be using pencil. So that is dashed. Sorry. I make mistakes just like everybody else. Okay, now we need to figure out where to actually shade this. If you look at this set that we listed here, I mean, those all make it true. So 0, 0, 0, 1, 0, 2, 0, 3, 0, 4, all the way up. So anything there is going to make it true. I think about it kind of as, two different zones. This zone would be inside. This zone would be outside. Now your solutions, they're all going to be the same. So if inside makes it true, then everything inside will make it true. If outside was a solution and it's satisfied, then everything outside would also make it true. They kind of stick together. Now, we need to actually test, and we kind of did a funky version of testing up here, but there's a much streamlined version. You're going to test a point, but your point can't be on the graph. Needs to be elsewhere. It can't actually be on this graph right there. So I'm going to pick at the point. Many of your teachers before, if you have ever heard of this, will tell you to pick 0, 0 as a test point, and that is just silliness right there. Use a little bit of logic in this and make your life a lot easier. If you can pick a point that has an x value that is the same as your locator point, when you substitute that in there, it's going to make it 0, and your life is going to become very, very, very easy and convenient when you're testing points. Don't do that. Think about it, and you're going to hopefully understand what I'm talking about in a minute. So here, let's pick a test point. It can be anywhere you want. Let's try that one. That's our test point. We will test negative 1, negative 1. We're going to put it in here into my inequality. If it comes out true, that's where you shade. If it comes out false, we're going to shade elsewhere. So let's see what happens. Negative 1, 2, negative 1 plus 1 squared minus 3. That is why we choose that, that vertical line right there. Because negative 1 plus 1 is 0. 0 squared is 0. 0 times 2 is 0. All you have left is negative 1 greater than negative 3, and your computation is very, very, very limited there. It's convenient. Negative 1 greater than negative 3. You think about that. Your answer will be either true or false. Negative 1 greater than negative 3. That right there is a true statement. Therefore, if that one is true, all the others will be true. And as you can see by some part of this list that we generated, those are where my solutions fall. So here's your art. There you go. Everything in there, in that shaded area, is a solution. You are welcome, art department. Actually, I'm sorry, because it's not very good. Let's get another example. Let's go with, how about absolute value? Y is less than or equal to negative 1/3. Absolute value of x minus 1 plus 2. That is an absolute value graph. I have videos on that if you need some help there as well. Locator point, opposite same, so 1, 2. This is a slope for absolute value. It is negative, so it opens down. I will go down 1 and over 3. 1, 2, 3. 1, 1, 2, 3. 1, 1, 2, 3. Same in the other direction. 1, 1, 2, 3. 1, 1, 2, 3. 1, 1, 2, 3. There you go. It is less than or equal to. My graph will be solid. Now you need to pick a test point. You can pick it anywhere you would like. I recommend picking some sort of point on that line that shoots through that locator point. Your life will be a lot easier. Let us try the test point of 1, 0. When we plug it in, we see if it's true. If it's true, that's where we will shade. If it is false, you will shade in the other area up above it. So let's see what happens here. 0 less than negative 1/3, absolute value of 1 minus 1. That looks nice to me, plus 2. Excuse me. 1 minus 1 is 0. Absolute value of 0 is 0. 0 times anything is 0. So we're left with 0 is less than 2. 0 is less than 2. That will be true or false. 0 is less than 2. 0 is less than 2. True. Therefore, where a test point is, that is where we will shade. Apologize about the vocabulary there. It is 0 is less than or equal to 2. I believe I just said less than. So let's take a look at another one. There's a nice image if you want to pause that. Hey. All right, we'll do one more quick one. Let's look at y is greater than or equal to negative 3 x plus 2 cubed minus 1. That right there is a cubic. I can tell by that exponent of 3, so graphing it. Parent graph cubic, if you need this one, it is opposite same still, so negative 2, negative 1. Bam. A is negative, so the left side is up and the right side is down. This is our inflection point. Slide over 1, hop up 3. Slide over 1, hop down 3. It is greater than or equal to, therefore it is a solid graph. We're going to pick a test point. Recommendation for you, don't believe to pick 0, 0. That's just silly. Use some thought here. I want to make that thing in there 0, so when I cube it, it's easy. Well, how do I make it 0? Well, that needs to be negative 2. Great. X needs to be negative 2 anything on there. So really any test point you want to use, you can use. Let's try negative 2, negative 2. Okay, let's see what happens when I sub it in there. Negative 2 is greater than or equal to negative 3. Negative 2 plus 2 cubed minus 1. Awesome. 0 cubed is 0. 0 times anything is 0, so you are left with that. Negative 2 is greater than or equal to negative 1. Negative 2 is not greater than or equal to. That would be false. This test point is false. That means every other test point in this area is also going to be false if we have done this correctly, and we have. Therefore, my shading and my solutions will all be on the other side here. Any point in this area, any point on the graph, because it's solid, that you plug in here will satisfy your inequality. Thank you much.